In a previous video, we showed you how with $99 you could set up your own Proxmox server and use that to gain the experience you need to become a cloud engineer. What we want to show you is the 2 skills you need to become a cloud engineer. Firstly, we are going to install Kubernetes in our Proxmox server, and then we are going to do a small Kubernetes workshop. After that, we are going to install Helm, and then we are going to do a Helm chart workshop. These are the 2 skills you need if you want to pursue a career as a cloud engineer. If you're studying computer science with a hope to get into the IT industry, well, this is an excellent opportunity for you to get the 2 most needed skills in the industry, Kubernetes and Helm. However, if you're not studying computer science and wish to pursue a career in IT, this video is also for you. You need to watch this video right to the end, and then we will give you a bonus chapter. We have provided a Proxmox Bible in our GitHub repository, and we will show you how to get it. So watch this video to the end. This is going to be a long video. By watching this to the end, you will have covered the most important cloud engineering skills. We recommend that you watch the first chapter and pause the video and take a break. We have logged into our Proxmox server, and the first thing we want to do is to create a VM so that we can run Kubernetes. So you will click the Create VM button. I wish to give this an ID of 400. Let's call it K3S Helm. Then we need to select the OS. Now we need to select our storage. We have a 2 terabyte drive, so we will select disk 2. And we have already downloaded an Ubuntu server ISO, so we will go down here and select our ISO. 2404 is fine. Click Next. We'll leave this as is. Click Next. They give you 32 gigs as a default size. You may want to increase this to 100 gigs. That's all we need to do here, and then click Next. In this server, we have 1 socket, so that's fine, but we will select 2 cores. Next. 2 gigs is not enough for a Kubernetes server. I will give it 4 gig or 8 gig. 8 gig is what we want. And this also depends on how big your server is. But for our requirements, 8 gig is more than enough. For networking, let's keep it simple. Don't change anything. Click Next. And we confirm by clicking Finish. And it'll start creating the VM. And eventually, we got our server. Here it is. Now we need to start the server. So click over here. Click Start. And open the console. We'll press Enter. We will pause the video until this is completed. Eventually we get to this stage. So now we press Enter. We recommend that you update to the new installer. However, to save time, we are going to click here and press Enter. And again Enter. And we are happy with that. Press Done. You need to note the IP address. This is 121. And Enter. We will pause the video. At this point in time, we will select to use the entire disk. So put an X there and press Done. And it's now giving us a summary. We are happy with that. Press done. And let's confirm. I like to give my server name the same name as my user for training purposes. It makes it easier to remember the user and the password. At this stage, you will provide your name, your server's name, your user's name or user ID, and your password, and confirm your password. And now press enter. We won't make any changes here, so press continue. We do want the SSH server, so do that. We don't need any of that. We will pause the video until this ends. And eventually we get to this. So now we need to reboot. We will pause the video. And now we can log in with our credentials. You need to excuse my screen from flashing, and that is because of the graphics card I have in my laptop. I now want to get the IP address. IP space A. And my IP address is 121. We will now close the screen. We will now open our terminal. Let's make it wide. We will now SSH to our new VM. You see, I need to run this command because I've used that IP address before. You won't have this problem. And now we can say yes and the password. The instructions for this part of the video can be found in our blog. Please have a look down below for the link. We start with the first link where we install Kubernetes into our Proxmox VM. The first thing we want to do now is to create a folder for our Kubernetes stuff. Let's create a folder inside the OPT folder called K3S. Before we can start our workshop now, we have 2 blog pages, and have a look down below for the links. We will run the command sudo su dash like that, and now we are root. Let's clear the screen. We need a folder to keep the Kubernetes stuff, and we would like to do that inside our OPT folder. So let's make a directory for that. Right, let's open the folder. The next step, we need to open our instructions. So let's open the Kubernetes workshop blog page. And if you look over here, you'll see there's a link. You need to open that link. And this will open the shell script that we need. It's masternode.sh. So let us now create the file. Run this command. And go here and copy this file and paste it in here. And Control S to save and X to exit. Now that we've done that, we need to make this file executable. We use chmod 775. You can use -X. And this should make it executable. Cheers. And now we can launch this. This is going to connect via GitHub to the Kubernetes binary and download it for us. You can see it says the downloading binary, and now it's starting the K3s Kubernetes. If you're working on a server, this is the lightest version of Kubernetes we recommend you use. Now that we've done that, we need to check if Kubernetes is installed. So we're going to run a kubectl command. Kubectl get node. You can type get nodes. That's a good sign. It tells us that our Kubernetes has been successfully installed. We are now going to do something we don't like doing. We are now going to be working directly from our instructions, but that is for your benefit. So you can see here we've done all this, we've got it working. So now we want to create a deployment file. It's known as a deployment manifest. Let's create a folder for our Kubernetes manifests. So let's copy this command. And open the folder. And now we will create our first Kubernetes manifest. And this is the deployment manifest. You see, with Docker, you only have one file, and that's known as the Docker Compose file. But with Kubernetes, your Kubernetes manifest can be considered to be a Docker Compose file on steroids. And in fact, we have more than one file. So the first one is the deployment manifest. And we go here and we copy this content here. Make sure you copy everything and paste it here. And Control S and Control X. X as in X-ray. Right, we've created the first manifest. Now we need to create a service manifest. So we will run this command. And we will copy this content. Control SX. Finally, we will create the service exposed manifest. We will prefer to call this the ingress manifest. So let's type it in by hand. Ingress. And hopefully we will remember the name when we deploy it. And then inside there, we will copy this content here. And save it. And now that we've done that, we're ready to begin our workshop. It is a very good practice when working with Kubernetes to always create a namespace. And it's the same good practice when working with Helm to create a namespace in the Kubernetes cluster. So this is a command you will be using quite a lot. And this gives us the ability to isolate different environments. You can consider a namespace to be like a virtual container where we put Kubernetes entities into that container. So let's do this. This is important to do this, and you'll see in the end why. And the namespace was created, and we can say kubectl get namespaces or namespace. It works with both. Right, and here we've created our Nginx namespace. Now we are going to run this command. You might remember we created the 3 manifests. Now it's time to deploy them to the Kubernetes cluster. Let me explain this command to you. When we say apply, we are telling Kubernetes that we are going to provide you with a file and we want you to apply this. In other words, to deploy this to the cluster. So here is the name of the file, deployment. Remember, we created this. And we also tell it we want this inside the namespace. So it's in this particular virtual container. And it's done that. After applying this manifest, we should have 1 or more pods in the cluster. But remember, it's got to be inside the namespace Nginx. So this is the command we run, kubectl get pod or pods. You can either say -- namespace or -n Nginx. And you can see we have 2 pods and they are both ready. And there were no fails. They both started immediately. So what we are doing here with the deployment manifest, we are installing our code or our projects into the Kubernetes cluster. If we go back and look at this manifest, you will see it says here replicas 2. So that's the reason why we have 2 pods in our cluster. So that's how we can control how many pods we want in our cluster. This is how Google does their Google search. They do it as an application and they spawn millions of pods across many data centers. After we have applied the deployment manifest, it is now time to do the same for the service manifest. If you look here, this is the command we will run. And that was successful. Now let me explain what the service manifest does. You see, your pod, as it was installed, it can't communicate with anything. We need to use the service manifest to wire the pod to the internal network. So now internally we can see that pod and we can access the web server internally. Now I'm going to show you an interesting command. kubectl get all. This only works if you specify the namespace. So here you can see the pods. We've got 2 pods and we have a service. And if you look here, this is a different IP address that's connected to the internal network. That is the IP address. You can access this web server internally, and it even opened the port 80. Remember, the IP address of the VM is 10.154.2.41. So this is an internal IP address. And now we are going to use the ingress. This will enable us to wire our pods externally to the internet if our server is internet facing. Copy and paste. And then we need to add the namespace Nginx. So that is the command we will run. If you did the same, that's a good idea, and make sure that you name the file nginx-ingress.yml. You could also call it YAML. It doesn't matter. But whatever you use there, you need to put here. And it's done it. At this point in time, I should be able to access my web server from my VM. So let's run this command. Curl localhost. You don't need the port number. And then you can see it's working. It's working in the terminal. And let's open our instructions again. And if you go here, we've provided you with the link. However, our IP address ends in 121. So let's open this in the browser and change the IP address. And there you are. We have this web server deployed through Kubernetes. Right, now we can continue with our workshop. Whenever you're working with the Kubernetes cluster, you will run this command to see that the clusters are up and which nodes are up. So let's do that again. Copy. Let's clear the screen. Run the command again. That's great. And we created the namespace nginx, so you can run this command. You should be able to see that. Right, there's my namespace. These are the steps you use when you're fault finding. And now we want to check what was deployed in the nginx namespace. So copy that command. And you will find 2 pods. You see there are 2 pods because that's why you have 2 here. But here's your deployment. We have a deployment with 2 pods. And you can also run this command instead of specifying an individual namespace. We can see what's deployed right across the cluster. So let's run this command. And you can see there are a lot of things that have been deployed, including traffic. K3s Kubernetes uses traffic as its load balancer, which is better than the nginx load balancer. Just as a matter of interest, we will run this command and we will explain it to you. What we are doing is we are telling Kubernetes to give me the pods. I'm specifically interested in the application nginx. So if there are other pods deployed in the cluster, this is going to limit me or filter them out and only display nginx pods. A wide output means it's going to give me a lot more detail. So let's run this command. Now you can see I've got 2 pods here. There's the one and there's the other. They're both running. You can see I have 2 IP addresses here. These are used to wire the pods internally to the internal network. And you will notice that they are both different. 9 and 10, they are sequential because they are in the same virtual network. And that is connected internally to our internal network. And it also gives us the name of the node where these are connected. If I had a high availability cluster, there would be more than one node and the different IP range in the one node to the other node. So we could have run a curl command, connect to the 2 pods using those IP addresses. And you could run this command as well. This will show you all the pods in all the namespaces. So let's do it manually. Output wide -- all dash namespaces. And this is a new cluster, so there's not much installed in pods. It's only how to, but in a production server, you'll be able to see all the pods with this command. Now we want to look at the services. So if you run this command, we should see our services. And there it is. This is the IP address. So we could actually connect to that with the curl command. You should be able to run this command as well. It's another way of, instead of typing services, you can abbreviate it as SVC. Let's clear the screen. This is a very useful command. It tells us how to connect to our services, in other words, the endpoints. Remember, we saw this earlier, 10 and 9. So this was how they are connected internally to the internal network. And those are the endpoints. And you can also run that command, get services, all namespaces. And you can see there are a lot more because we have our traffic load balancer and it's listening to this IP address, and externally it's listening to port 80 and 443. Web server, load balancer. Now with scaling, we can use a command to increase or decrease the number of pods. I prefer to run this command, kube control get pod or pods, and we've specified our namespace, and we can see we have 2 pods. Now we are going to scale it to 4. Let me explain this command. So scale the deployment, we have currently 2, and we've set the number of replicas to be 4. So we're increasing it to 4. This is the deployment name, which we see over here, and then the namespace Nginx. You must have this and you must have that. Otherwise it won't work. And now it's scaled. And if I go back to deployments, and if I say get pods, deployment or deployments, and pod or pods. So let's see. There we are. We have 4 pods. We want a wide output of our pods. So let's run it now. And you can see the internal IP addresses. Remember, we had 9 and 10. We now have 13 and 14. So it kept these 2 and it added us 2 new ones. It originally created 11 and 12, but then I scaled it back to 2. And then when we scaled it again back to 4, it created new pods, 13 and 14. So we are going to run this command. But now you need the pod name. So let's take the whole thing here. And paste it. and we need to be in Nginx namespace. So here's all the details about this pod. And you will notice that it's in the YAML format. So you could have piped this into a YAML file. This could be useful in a production environment as it gives you all kinds of useful information about your pod. Another important feature is to access your logs. So the command is kubectl logs. Make sure you don't leave the S out. And let's select this one here. And the namespace, -n and Nginx. Let's try the earlier one. This one over here. You can even type -f if you want to tail the log. And then you need to type Control-C to exit. Or you can run it without the F, like that, and it'll display you the log. You see, the first log that I looked at was a new pod, whereas the second log that I looked at now was one of our original pods, and we'd been playing with that pod, so it had activity. Remember, we opened it in the browser, so it's had a record of a get command. So it had a get command from the browser, and it had returned successfully as well. And finally, this is one of the reasons why we put things into their own namespaces, because if I delete the namespace, it'll delete everything inside it. It's a way to do a cleanup in the cluster. So you would run the command like that. So that's what you would run, and then it will delete this namespace with the Nginx deployment service and ingress. It will all be removed. Before we start this section, we'd like to remind you that if you watch this video to the end, we got a bonus for you. If you are watching so far, it means that this video is either interesting to you or useful to you. We would like you to benefit from our channel, so please subscribe to our channel, as 70% of our viewers have not subscribed. You may ask, what is Helm and what is a Helm chart? Consider Helm to be a package manager for Kubernetes. It is a very easy and a very powerful way of installing applications into your Kubernetes cluster. A Helm chart is like a predefined template that you can use to deploy an application into your Kubernetes cluster. We deploy applications to our Kubernetes cluster with a single command. This is a lot easier than with Kubernetes, where you use one or more YAML files that you have to create and then deploy them into your Kubernetes cluster. Helm simplifies the way we update and do a rollback. This is especially important in a production environment where you have an easy rollback. Now let's get our hands dirty. In the previous session, we created a VM, we installed Kubernetes on it, and this was the IP address of the VM, and we opened it up in our terminal. We will now create a folder called Helm inside our OPT folder. -p, and then we will open this folder. From our instructions, we've provided you with the link to the latest releases of Helm. So if you click this and open it in a new tab, and you go here and we're looking for the AMD one, that's that there. And that's the file you will download. Now, to save you time, we have it in our instructions. So this is the command that we have. You will run this command. And it's downloaded the file. We now need to extract it. Let's first see what we got. ls-l. And we got this file here. Now we will extract this file. This is the command. And now if we have a look in the folder, we now have a Linux directory over there. We want to copy this into our user bin folder. So we will run this command that will move this folder into our user local bin Helm. And to test this, we are going to run this command. And you can see this is the latest at the time of this video, version 18, 3.18.3. We need to look at our instructions now. We don't like doing that, but anyway, this is why. When you try to run Helm in an Ubuntu server with K3s Kubernetes, it won't work. You need to tell Helm where to find the Kubernetes. So we need to create this folder. And then we need to copy our K3s YAML file, in other words, a configuration, into that folder. So this is the command you will run. Having done that, now we can work. There are many Helm charts out there, so let's show you how to find one and use it. You will open this link in your browser, and from there you can find many Helm charts. Let's do that. Okay, and we want Nginx. So we will search for Nginx. And the one we want is this one from KubeSphere. You could use the Bitnami one. It's very good, but for the sake of this video, we've tested it using this one. So let's open this. Now, when you go here, they will provide you with a few useful things. There is a values file that you can use, and the information for that can be found here. These are all the different values that you can pass for this Helm chart. What's more interesting to us is this. Before you can use this Helm chart, we need to add the repository of KubeSphere to our Helm. So copy this command, run this command. We've already done that, so that's fine, but in your case, that's what you would do. After we have added this KubeSphere repository to our Helm, we need to run an update command. So let's run the update command. Right. It's updated our Helm repositories. As we mentioned earlier, it is important when you work with Kubernetes to create a namespace. So we will create the Nginx namespace. If you haven't deleted your previous Kubernetes Nginx namespace, then run the command kubectl delete namespace Nginx. However, we have done that in the cleanup. So we can run this command and you'll see it says it already exists because we were testing. That's fine. And now we are going to do something special. Helm Charts provides a feature called a dry run. This is how we deploy applications to our Kubernetes cluster using Helm. We say Helm install. When we did that with Kubernetes, it was kubectl apply, and then you pointed to the file that you wanted to use. So this is very similar. So let's copy the command and I'll explain it. If you look here, Helm install, we are giving this a name, Nginx, and then we are specifying the repository, so that's the kubesphere Nginx. We are specifying a version we want to deploy. We want this in our Nginx namespace, and then we have dry run debug. Always use this when testing new Helm charts. What this will do, it will simulate deploying to your Kubernetes cluster, but it will show you all the errors. So let's run the command. And we get back a YAML. So this is basically the Helm chart that we are going to deploy into our Kubernetes cluster. And we also get some additional information here. The developers of this will provide you with additional information how to use this application. You see, they're providing you with all kinds of useful information. And now we can deploy that application because the Helm chart was good. And it was successful. There we are, deployed. So now we can use Kubernetes commands to see what we got. So let's see what deployments we have. In this case, we have one deployment. The name is Nginx, and it's run, and it's successful, and it's available. We can also look at the pods. Pod or pods. There we are, it's running. And now let's have a look at what we have deployed using Helm. This command will allow us to do that. So all your applications you deployed in this namespace, you can now view. And you can see we have this Nginx. The namespace is Nginx revision 1. As with all software developed, you need to upgrade what was deployed in your production cluster. So Helm provides us with an upgrade command. And if we look here, this one does the dry run as well. So let's have a look here, Helm upgrade. Everything else is the same with the dry run. That is good. That tells me the deployment can be done, and then you would deploy that. So let's do the next command, Helm upgrade, like that. You will notice that the revision number here has incremented. What you see here is a new revision number, revision 2. It started with a 0. We were testing this. And now we can have a look at the history. So if we go and say, By running the history command, we can see what happened here. Let's have a look. Now, if we run the Helm history command and we gave it the name that we used to create it, which is my nginx, and the namespace like that, we can now see the history. So the first revision 1 was when we created the application and it was installed successfully. The second time here is when we upgraded the application. Now, in every production environment, occasionally you do a failed deployment. We want to simulate that. So we are going to run an upgrade and pretend that it failed. And now if we run history, we should have 3 revisions. Here they are. So now we are going to say that revision 3 failed and we want to roll back to revision 2. We will run this command and we will replace that revision number with the actual number. We want to roll back to 2, revision 2. The rollback was successful, and let's check our history again. And you can see here it's telling us that it rolled back to revision 2 and it's created a new revision 4. This is one of the benefits of using Helm charts in your Kubernetes cluster. And now for the cleanup, we will say uninstall, and that will remove the nginx deployment. It does not delete the nginx namespace. So let's run this command. And if we go back to history, you'll see it's gone. Now comes the dangerous part. When doing training, we always like to keep the Kubernetes cluster clean. And you should do that in your own cluster. But never do this in production, or you need to revise your CV. So the kube control delete namespace is going to wipe out nginx. And here's a bonus chapter. We've provided you with the Helm commands that we used in this lesson, where you could specify and add the repository, where you could do an update of the repository, where we could install doing a dry run, and here where we could do a normal install, and here where we could list what's in the namespace nginx, and here is where we could upgrade our Helm chart, and here we could look at the history so that we could see if something failed to roll back. And here was the rollback command that we used. So there it is. And then finally, we wanted to remove that deployed nginx. So here was the command to do that. In addition to that, we've provided you here with a cheat sheet. Feel free to print this or drop it into Word. And now we have something special for you. We have provided a link to our channel repository. Click here to open it, and click here and wait for the preview to open. This is our Proxmox and Docker Bible. You are welcome to download this. You can download it by clicking this link. And please call this Proxmox and Docker Bible. Now leave us a comment and tell us if you would be interested in us creating a Kubernetes Helm Bible. If we get enough interest and enough comments asking for the Kubernetes Helm Bible, we will create it and put it up there. And if you subscribe to our channel, you will be able to get it. We trust you found this both interesting and useful. Please subscribe to our channel, give us a like, and now we have an interesting thing we do in this channel. We will greet you in 6 languages. Cheers, dude. Baie dankie, tot ziens. Grazie mille a me, ciao. Jesus inaderfe. Auf Wiedersehen, mein Freund. Namaste. Namaskar. Domo arigato, tomodachi, sayonara.